All right, welcome back to another part of Recitation OG. In this recitations part, we'll be talking about AWS EC2 instances, your virtual machines in the cloud. We'll be talking about AMIs, what they are. We talk a little more about instance types, which ones to use, security groups, how do you configure them, what are SSH secrets, where do you keep them in your system, and we also talk about how do you stop and terminate your instance. Perfect. Let's dive right in. As you remember, this was your console home, your AWS home dashboard. You will navigate to EC2 dashboard from here, search for EC2 and go on over. This is your EC2 dashboard. Now to launch an instance, the first thing that we'll have to decide is what kind of operating system do you put on your computer. To select that, we'll go on and select something called an AMI from an AMI catalog, which you'll find on the left-hand sidebar. Click on that and it brings you to this page. All right, now what's an AMI? AMI stands for Amazon Machine Image. These are basically the operating system and the other drivers and softwares that you need to run your specific task, your development environment, so to say. Which AMIs to use? Because there are many to choose from. Well, there are a couple that we suggest. There are two, which we'll briefly talk about. One is the AWS Deep Learning AMI, and the other is AWS Deep Learning Base AMI. The base AMI would have the drivers to make sure that you can run your training jobs in a CUDA environment, in your CUDA job setup, whereas the other non-base AMI would also have Anaconda environments that would have the packages and the frameworks already installed, such as PyTorch, scikit-learn, and whatnot, to make your life easier and faster for you to run your training jobs. Of course, this comes at a cost of the space that it takes, whereas the base AMI would be much smaller to use. But for the purposes of this demo, we'll be using the AWS Deep Learning AMI, the full-fledged one. All right, let's search for it. We go ahead and type Deep Learning AMI in the Quick Start catalog type, scroll down and find Deep Learning AMI here. By the way, if you are looking for the base AMI, you would find that in the community AMIs right here by searching for base. But as we talked about, we'll be using the vanilla Deep Learning AMI in the Quick Start guide. And this is the one that we'll use. So we go ahead, select this, scroll to the top. On the right-hand side, launch the instance with AMI. This would bring us to the new dashboard, which shows different settings that we'll configure about launching an instance. Now, let's name our web server first. For the purposes of this video, I'll call it 11785 demo. All right, now we've already selected the OS image. In this case was the Deep Learning AMI, Ubuntu 18.04 version. Next, we choose the instance type, that is the configuration of our computer itself. As you can see, and we talked about last time, there are multiple ones that will be available for you, which ones to choose. Discuss that briefly. You go back to our slides, and we see the recommended AWS GPU instances that we'll be using for our case. Specifically, there are a couple for P-type instances, which give you a lot of Tesla V100 GPUs. We also have G3 instances, which give you considerable, not so powerful GPUs, but considerable number. For the purposes of this specific video, we'll be using a G4 type instance, which offers up to 4 NVIDIA T4 GPUs, which is sufficient for our use case. But go ahead, for your specific project, you might need more compute power, and so we introduce it here. Let's go look at this in a little more detail. The recommended instance types, dug deeper, are these. First, let's talk about T2 Micro. T2 Micro would give you one vCPU, 1 GB of RAM, and should be used for test purposes only, running small applications. The other two that we would specifically be using for our training purposes is G4DN Extra Large, which gives you 4 vCPUs and 16 GB of RAM. This will give you one T4, 16 GB VRAM GPU, and up to 125 GB of additional ephemeral NVMe. This is ideal and has been enough for most of my use cases, but depending upon how hungry your specific project might be, you might also use P3 X2 Large, which can give you up to 18 vCores, vCPUs, 61 GB of RAM, and one NVIDIA Tesla V100 with 16 GB of VRAM. But mind you, these might be fast, but they're expensive as well. Let's go back to our instance creation page. Choose our instance types. As we talked about, we'll be choosing G4D and X large. Now, to connect to your instance securely, we would need something called a key pair. You would keep the private key and the instance keeps the public key. In this way, you will be, whenever you connect to your AWS instance, you know you are connecting in a secure fashion. For that purpose, if you don't have a key pair, go ahead, create a new key pair. We'll call this 11785 demo again, and choose an RSA type, private and public key. We click on create key pair, and this would go ahead and download a key pair on our default downloads repository. Now, where do you keep this key pair, or the specific key, or our PEM file? For Windows users, you should keep your keys in your C users, your username, and a .ssh folder. It's a hidden folder, so you might have to show that up. And then your PEM file. For Linux and Mac users, you should go to your home, create a new folder if you don't have one, just like Windows users, and keep your PEM file there. Now, let's go to our Finder. And from the top, look for .ssh folder. Now, I have my hidden folder shown. To show them for your case, you would want to hit Command Shift dot. This would show or hide your hidden files and folders. We go ahead, show them. In our case, go to .ssh and paste our file here. For this case, we go to Downloads. We have this PEM file. We copy this and paste it here. Perfect. Once that is done, we go back to our instance page, and we'll talk about a little more about how to use your key a little later. The next thing that we look for are the network settings. All right, network settings help you create something called a security group. Imagine security groups as being a cover which keeps all your resources inside. So you would have to allow traffic to enter this cover for you to interact with your resource. In this case, this is an EC2 instance. So we'll do it from the scratch. Go ahead, create a security group. We'll click on the edit button so that we can see more controls. Call our security group 11785 demo. And allow SSH connection to your instance. This is the specific port that uses SSH, which we'll talk about a little more in the upcoming video, as well as in this video. The port would be 22. We would allow any IP to connect to this system, because you would be normally bouncing around from your school to your home, and your IPs might change. So we don't restrict our source type. We go ahead, add another security group with the custom port range starting from 888. Now, if you're a Jupyter user, Jupyter Notebook user, you would know if you start a Jupyter session, it is normally serviced on the 888 port, and that is why we're creating this. The source can be from anywhere. I'm doing this just to make sure we completely understand what it means to create a security group, but we'll dive a little more deeper when George talks about this in the next part of the recitation. Moving on, we'll configure storage. 140 gigabytes is more than enough for us. And then we can go on and click on advanced details. In the advanced details part, we will be exposed to an option called request spot instance. If you remember from the last video, we talked a little bit about requested instances and running instances. Requested instances are spot instances and running instances are on-demand instances. If you do not select this option of requesting a spot instance, we would basically be requesting an on-demand instance, which is spun up as soon as you click on launch instance button here. But just to make sure that you understand what a spot instance is, let's dig a little deeper. We click on spot instance and click on customize. This will open up a plethora of other options that you can choose from. Now let's talk a little more about how do these instances differ. A spot instance is an instance that you request AWS. Can you please give me an instance at a certain rate? This rate is something that you can specify here. You set a maximum rate at which you are ready to pay for the instance, and beyond which the AWS will go ahead and interrupt your specific machine. How does it interrupt it? Depends upon what kind of request is yours. We'll talk a little more about what these types mean. Essentially, the rates differ because there is more traffic, more request on the Amazon side. How do you know what should be the price? Well, go back to instances, vantage.sh, and look at the price that is offered for this specific kind of instance. In this case, you see it is 0.15 for 1 hour. Probably add another cent to it just to make sure your instance is actually up. We'll go ahead and now talk about instance request types. Just like we talked about on-demand instances, they are spun up as soon as you click on the launch instance page. The interruptions don't happen. Basically, you are the one who terminates your instance. We'll talk about how to terminate that later as well. The cost is basically the regular cost, which you'd see is okay. But in case of spot instances, you are allocated that service, or in this case, the EC2 machine, if there is capacity to allow you for those EC2 instances in that AWS region. Also, if your price is lower than the actual price of the EC2 instance right now is lower than the threshold that you've set. Once that is done, persistent spot instances are hibernated or stopped once that threshold is reached or the capacity is reached. What do you mean by stop? Whereas the one-time spot instances are terminated. Let's talk a little more about what these mean. In terms of stop, imagine stopping as shutting down your computer, whereas terminating is basically throwing your computer into a trash crusher. All your processes and your memory is completely gone, whereas in the case of stop, your memory and your RAM is basically serialized and kept. When it is spun up again, when you have more, AWS has more resources or the price is lower than the threshold, your system comes back up as it was in case of stop, not in the case of terminate. In terminate, it is permanently erased. Any external storage that you have added to your EC2 machine, such as EFS or EBS, which we'll talk about in the next part, this remains unaffected. Ephemeral drives in either case are completely destroyed and the cache is lost. Let's go back to this slide. The good thing about using a spot instance is it's extremely discounted. Other TAs tell me that they have found this to be pretty consistent and terminations are very rare. So go ahead, try your luck. For the purposes of this video, I will not be requesting a spot instance just to make sure my system works. Other options are optional and you can go ahead read about them on your own time. With all of that done, let's go ahead, launch our instance. As you can see, our instance is launched. We go on and view all the instance and see that this specific instance, the 11785 demo, is up and running. Let's click on instance ID. This will take us to instance dashboard, where we can see all the details of our instance. Now let's talk about connecting to this instance. How do we actually connect to this instance using SSH? To do that, click on connect. Click on SSH client, that is the third tab on top, and follow the instructions which are given by AWS. They say we have to open an SSH client. Well, in case of Windows, Windows now natively supports SSH using OpenSSH in your command prompt. In case of Mac, it has always been supported, so let's bring our terminal up. I use an iTerm shell. Let's clear this for now. All right. Now then it asks us to locate a private key file, which we already know where it is. Remember, it's in the root folder of your user .ssh/. Perfect. Now it asks us to run a command that basically goes as chmod 400 and the PEM file's name. Before doing that, let me come home. Once I'm home, I'll be able to see all my files, to see all my hidden files as well, hidden files and folders. I do ls-a, and I can see I should have my SSH folder here as well. Once I know that, I cd into my SSH folder and then paste the instruction that was given here. Running this command basically makes sure that your file is now unoverwritable. We go ahead, do that. And then it says we have to connect to our instance using its public DNS using this command here. Go ahead, copy that, go to your terminal again, paste, and press enter. As you can see, let me zoom in here a little so it's easier for you to see. You will be asked to continue connecting to this system and save the fingerprint. You go ahead and say yes. Once you do, the system saves that specific instance as something that it knows and doesn't bother you once the next time you try to connect. Once that is done, you will be able to see that we have successfully connected to our system, EC2 system. Wow, congrats. Let's look at the different environments that we have. I promised you that we'd find Anaconda environments. Let's look at them. Well, it took its time, but as we can see, there are different environments already configured for us to directly use and run for our deep learning cases. All right, perfect. Let's close this instance of our shell right now. And now we talk about how do you shut down your system. Remember, these are instances which are using up your credit and are expensive. Once your job is done, you would want to stop these instances. You can do it from either the instance dashboard. Go ahead, select the specific instance that you want to stop, go to instance state, and terminate your instance. Remember the difference between terminate and stop. In this case, we are terminating the instance in the sense killing all the processes, losing all our ephemeral storage, as well as neglecting anything that we would have stored in our system. Click on terminate instance. Confirm that. It would say it's shutting it down. Try refreshing. Well, AWS will shut it down for you. And now it will not be on your cost bill. Please remember to stop your instances when you're done with your work And with that, I would leave you in capable hands of George to take on the recitation forward. And I will see you on Piazza.